Okay, let's do exercise number 2. Determine resistance through direct measurement. Connect a multimeter set to measure resistance to the resistor. Record the resistance in data table 2. Repeat for the other 2 resistors. Find the percent error with the expected value. So you can see the 3 resistors off to the left and the multimeter. And let's look a little bit higher at the multimeter there. You can see that it's dialed up to the symbol ohm, that's white. Now you see a capacitor there in yellow, but we don't want to measure capacitance. We want to keep it in ohms. And you can actually see that it says OL, which is overload. It's not connected to anything now, so it'll say overload in mega ohms. And if we look down here, we can see the patch cords are connected to the red plug. You see the ohm symbol on there, and then the ground or the COM. So now all we have to do is go over here and measure our resistors. So I'm going to take the top one first, and it doesn't matter resistors. You can hook it up black to red, either way. Now what we're going to do is I'm going to go over, and you can write down what it says on the multimeter. Actually, now it's an ohm meter because it's measuring resistance. We call it, it's in the ohm meter mode. So everybody got that number? 265.2 ohms. So that's for the top one. This was the one that was red, blue, brown. Okay. So now what I'm going to do is hook up the multimeter to the second one, and you can see the value for that one, 98.5 ohms. So you can write that down. And that one was the brown, black, brown, I believe. It's kind of hard to see it. So we're going to now unclip this one and clip onto the last one, and you'll have your last measurement for this. This one is 66 point, okay, it's flipping back and forth. It looks like it's 66.7 ohms. Alrighty. So you write all those three in your handbook. I'm saying data table. Now what you're going to do is find the percent error, and just to remind you how percent error is made. Oops. Percent error is equal to the absolute value of the differences between your experimental value minus your actual or expected value. And you divide that by the actual value times 100%. So in this case, the actual value, that's the one that, the color band value, the one that you actually did from before, or the expected, this is the experimental value, the one that I just did on the ohm meter. So these are the banded ones. You can call it the actual experimental or I'm sorry, expected value. And this is the value that you got from the ohm meter. So take the ohm meter, subtract off the value they got from the color coding, and divide it by the color coding value. And this is the absolute value. So if it comes out negative, it doesn't matter.